In Chapter 8, we will have the opportunity to discuss water balance and the minerals. The minerals, many of them, play an important role in fluid balance. The story posted on this slide is about an 11-year-old boy who was forced to drink 92 ounces of water in 4 hours and ended up dying. Water intoxication was the cause of death, and water intoxication is excessive body water contents. Having excess fluid can cause a condition called hyponatremia, which is decreased blood sodium concentration. Sodium and chloride are the major extracellular minerals, and potassium is the major intracellular mineral. In this chapter, we'll have the opportunity to discuss in more detail how some minerals play a role in fluid balance. When water intoxication occurs, there is too much fluid in the extracellular space. In order to compensate for excess fluid, the cells will take up fluid. When the cells take up too much fluid, and they are in what's called a hypotonic solution, they will end up swelling and bursting, and that's what happens with hyponatremia in extreme cases. In Chapter 9, you'll learn about water and the minerals. Water makes up 60% of an adult's body weight and more for a young child. Water functions to maintain our blood volume and aids in normal body temperature regulation. It also acts as a lubricant and a cushion. Extracellular fluid encompasses all of the fluid that occurs outside of the cell. It includes interstitial fluid, which is fluid between cells. Water functions as an essential nutrient to carry other nutrients and also waste products. Water maintains the structure of small and large molecules and participates in metabolic reactions. Water also serves as a solvent for other nutrients, including the minerals. The part of the brain called the hypothalamus, which is pictured here, is responsible for detecting thirst and triggering us to drink fluids. As we get older, the ability to detect thirstiness decreases, and so dehydration may occur more commonly in older people. Water imbalances include water intoxication and dehydration. Water intoxication is when there is excessive body water contents. It's rare and can occur when someone drinks too much water in too little time, as was discussed at the top of the lecture, or when someone has a kidney disorder that reduces the amount of urine produced. Dehydration occurs when water output is greater than water input. Let's take a look at some of the signs. If someone weighs 100 pounds, then 5% of their body weight is equal to 5 pounds. Dehydration is categorized based on the percentage of body weight lost as water. So a 100-pound person who loses greater than 5 pounds of their body weight as fluid has severe dehydration and is at risk for coma and even death. While mild dehydration is called mild, it can result in serious problems with energy, kidney function. It can cause low blood pressure, or you could just feel thirsty. There are a number of mechanisms in place to help the human body to decrease the likelihood of becoming dehydrated. The brain, the kidneys, and the adrenal glands act to regulate water excretion. The pituitary gland is nicknamed the king gland because of the dominion it has over many body functions. The pituitary gland secretes antidiuretic hormone, also referred to as ADH, and is also known as vasopressin. When the blood becomes too concentrated, ADH will act on the kidneys. It will stimulate the kidneys to reabsorb water. Whenever we lose too much fluid, our blood pressure falls and our blood volume drops. The kidneys will respond to this through the renin-angiotensin system. Renin is an enzyme that's released by the kidneys in response to low blood pressure. Renin acts on the kidneys to help them retain water. Aldosterone is released from the adrenal glands and also causes the kidneys to retain water. The longest a human has gone reportedly without consuming water is 18 days. Andreas Mahavich, an Austrian man, was reportedly left in a prison holding cell for 18 days in 1979. Your textbook says that a person can go no longer than 3 days without water, so we'll go with that one. The minimum water that needs to be excreted per day is 500 milliliters per day to allow for normal metabolic processes. 500 milliliters is equal to US 16.9 fluid ounces. The average water that we lose in one day from all sources, which we'll go over on the next slide, is 2.5 liters. In Table 9-2, you can get an idea of how water balances sources with losses. We get water from liquids, typically in the range of 550 to 1,500 milliliters per day. From foods, in the range of 700 to 1,000 milliliters per day. And metabolic water produces 200 to 300 milliliters per day. This gives us a range of 1,450 to 2,800 milliliters of water input. We lose water in urine, sweat, in our breath, and in feces. Losses will equal input. Table 9-3 shows the varying percentage of water by weight in some beverages and foods. Notice that with oils, white sugar, and meat fats listed at the very bottom, 0% is water. In fact, it would be very problematic to have water and oil if you were frying something. With fruits and vegetables, over 95% of the weight can be as water. So water can be obtained from all types of beverages, including coffee, and fruits and vegetables. The Dietary Reference Intake Committee has set adequate intake recommendations for males and females. For adult males, the adequate intake for water is 3.7 liters per day from all sources, and for women, it is 2.7 liters per day. There are a number of factors that can contribute to the varying water needs among individuals, including the types of foods consumed, the environmental temperature and humidity, physical activity level, and other factors. Someone who works outside in a hot, humid environment in a lot of equipment like a firefighter can lose significant amounts of water, and along with that, magnesium, potassium, and sodium. And so his or her fluid requirements are going to be dramatically increased. If you are curious to know if you are hydrated enough, you can use a chart to determine hydration level. If you have a darker urine, you need to drink some more fluids. Fluid balance is maintained with the help of some of the essential minerals. The essential minerals are circled here on the periodic table of the elements. The minerals are able to form salts in the body. Whenever we sweat, we lose minerals like sodium, potassium, magnesium, and selenium. We need to replace minerals through our dietary intake. Supplements are discussed throughout this lecture and at the end of the chapter in the Nutrition and Practice section. Essential minerals are obtained from our food and water. Minerals act as electrolytes. Some of them conduct electricity. Mineral salts like sodium chloride can dissociate in water into charged particles called ions. Ions carry a charge, anions carry a negative charge, and cations carry a positive charge. Electrolyte balance in the body is regulated closely. There are proteins in our cell membranes that are able to shift ions across cell membranes, and our kidneys function to regulate sodium and water. If we compare the body's total electrolytes to urinary electrolytes, the body's total electrolytes remain constant, while urinary electrolytes will fluctuate as necessary to maintain the constancy of the body's electrolytes. The minerals can form electrolyte mixtures that act as buffers to maintain a constant pH for our survival. Buffers are compounds that can donate hydrogen ions, which are positively charged, or accept hydrogen ions to maintain a constant body pH. The primary regulators of the acid-base balance in which our survival is dependent on are the kidneys. This is the periodic table of the elements. It shows the major minerals and the trace minerals. The essential major minerals are needed in the diet in amounts greater than 100 milligrams per day. They include the 7 listed here: sodium, chloride, calcium, magnesium, phosphorus, potassium, and sulfur. Also referred to as sulfate, which is the oxidized form of sulfur. Sulfate is the form that is found in food and in water. Sulfur is also part of the vitamins biotin and thiamine. The trace minerals are needed in smaller amounts than the major minerals, but still are extremely important. A deficiency of iodine, for example, can cause brain damage that can be temporary or permanent, depending on how long the deficiency goes on. Iron deficiency is the most common nutrient deficiency and is estimated to affect billions of people worldwide. The question asked here is, what is the distinction between major minerals and trace minerals? The major minerals occur in larger amounts than the trace minerals do in the body. The major minerals are required in amounts greater than 100 milligrams per day, and trace minerals are required in amounts less than 100 milligrams per day. All of the major minerals influence the body's fluid balance and have other specific roles. Worldwide, it is estimated that 1/3 of school-age children are iodine deficient. The DRI committee has identified shortfall minerals that Americans are at risk for not getting enough of. They include calcium, magnesium, potassium, and iron. We'll talk about these in detail. Magnesium is associated with insomnia and muscle cramps when you don't get enough. Potassium deficiency is associated with elevated blood pressure and may make people more sensitive to the effects of sodium in the diet. Excess sodium is associated with elevated blood pressure. Iron deficiency is the leading nutrient deficiency or most common nutrient deficiency worldwide. There are two types of iron that we get from food: heme iron, which is more readily absorbed, and non-heme iron. Sodium is an essential mineral and acts as the principal electrolyte in the extracellular fluid. It helps to regulate our fluid volume. It is essential for nerve transmission and muscle contraction and acid-base balance. However, in the United States, we overconsume sodium. Average intakes are above 3,400 milligrams per day, and the tolerable upper intake level, also known as the UL, is 2,300 milligrams per day. There's no shortage of sodium in the diet. It is very easy to overconsume sodium. The top contributors of sodium in the diet, hopefully you're not getting too much, include things that we commonly eat, like pizza and pasta dishes in the United States on average. So if you overconsume anything on this list, have your blood pressure checked. As we get older, our blood pressure naturally decreases. Our blood vessels age. Over half of the people over the age of 65 have high blood pressure. Processing of foods, as we'll see later on, decreases the amount of potassium that it contains. Most people don't get enough potassium in their diets. Potassium from supplements do cause risk, and so it is a recipe for having hypertension. Cardiovascular disease is the leading cause of death. So it's advisable that you pay attention to your food sources. We'll see in a figure from your textbook on the next slide what processing does to potassium content. There is a correlation between sodium and blood pressure. The more sodium in the diet, the higher blood pressure tends to be. Discussed in this textbook is the DASH approach. DASH stands for Dietary Approaches to Stopping Hypertension, and it reduces dietary sodium and increases the amount of potassium from foods, also magnesium and calcium in the diet. Figure 9-2 shows what processing does to the sodium and potassium ratio in foods. Generally, you see an increase in sodium and decrease in potassium. While you can buy reduced sodium options for some products, the potassium is lost. Here is a sample of the DASH eating plan for a 2100 calorie eating pattern. The DASH diet limits red meats and sodium. Sodium intakes are reduced to 1500 milligrams in a lot of cases. The adequate intake for sodium is 2300 milligrams. The DASH eating plan is full of foods that are rich in magnesium, calcium, potassium, and fiber. Saturated fat and trans fat are also limited in this diet. Okay, so let's look at the next major mineral, chloride. Chloride is found in conjunction with sodium, usually as salt. Salt is a major source of chloride in the diet. Most people in the United States get enough chloride. Chloride is a major negative ion called an anion of the extracellular fluid. It works to maintain our fluid, electrolyte, and acid-base balances. Chloride is also found as part of hydrochloric acid in gastric fluid. We need hydrochloric acid to maintain the pH of the stomach so that we can effectively absorb vitamin B12. A deficiency of the major mineral potassium can result due to excessive diarrhea or excessive vomiting. Potassium is a cation, meaning that it has a positive charge when it dissociates in water. It is the principal cation in the intracellular fluids. Potassium is needed to maintain a regular heartbeat and functions in nerve impulse transmission and also muscle contraction. Potassium and sodium switch places briefly during muscle contraction. Where potassium is in the body is tightly regulated, and the deficiency of potassium can lead to elevated blood pressure. Excess losses of potassium may be associated with dehydration or prolonged vomiting or diabetic acidosis. Even certain medications with regular use can result in potassium deficiency. Potassium wasting diuretics that decrease the amount of water that the body retains can result in potassium deficiency, as well as steroids that suppress immune response and decrease inflammation, and cathartics, which are strong laxatives. Deficiency of potassium is associated with an increase in blood pressure, an increased risk of kidney stones, and increased bone turnover, so it's not good for your bones. Toxicity from potassium results from overconsumption of medication or supplements, Certain diseases, some kidney patients require potassium restrictions, and no upper limit for potassium has been set. Potassium injected into a vein in excess will cause heart failure. Potassium from supplements can result in toxicity. So potassium-rich foods include beans, dairy milk, soy milk, potatoes, sweet potatoes, watermelon, avocados, and bananas. Low potassium intakes are associated with increases in blood pressure, and getting ample potassium is associated with a reduced risk of cardiovascular disease and stroke. Calcium is an important major mineral. We need about 1,300 milligrams of calcium per day. 99% of calcium is found in the bones and in the teeth, and 1% is found in the body's fluids as ionized calcium. Ionized calcium is important in regulating our blood pressure. It is tightly controlled. We also need calcium in the body fluids to help with muscle contraction and relaxation, for nerve functioning, for blood clotting, for our immune system defenses. Calcium also allows secretion of hormones, digestive enzymes, and neurotransmitters, and activates cellular enzymes that regulate other processes. The calcium found in our bones is formed from calcium salts. Calcium is found with phosphorus and magnesium in the bones and forms crystals on a collagen matrix. Collagen is a protein. You can see the matrix that is formed in this image of trabecular bone. Calcium helps us to maintain our bone density, and if we don't get enough calcium when we're growing, it can result in stunted growth, and when we're adults, it can lead to osteoporosis. Bones are not inert like rocks. They are living tissues that continuously gain and lose minerals in an ongoing process called remodeling. The phases of bone development include the active growth phase, the peak bone mass phase, and the bone loss phase, which is the downhill phase. During active growth, bones are actively growing in length and size and density. This occurs between the ages of 0 and 20. Peak bone mass overlaps with this phase and occurs between 12 and 30 years of age. In the final phase, bone resorption exceeds bone formation, and so this is the downhill slope. So if possible, it is advisable that you get adequate weight-bearing activity and consume a diet that is adequate in nutrients to optimize bone health. Ionized calcium in the body fluids accounts for 1% of the calcium in our body. Ionized calcium helps to regulate the transport of ions across cell membranes. It helps maintain normal blood pressure. It is essential for blood clotting, muscle contraction. It allows the secretion of substances and activates cellular enzymes. The 1% of Calcium that is found in our body fluids is tightly regulated. When calcium in our blood gets too high, vitamin D acts along with other hormones to deposit calcium into bone to bring calcium levels back down into a healthy range. When our calcium gets too low in our blood, the small intestines will act to absorb more calcium. Bones will release more calcium into the blood, and the kidneys will excrete less calcium to increase blood levels of calcium. How is blood calcium affected by chronic dietary deficiency of calcium? Well, blood calcium is not affected by chronic dietary deficiency. Instead, bone calcium will be depleted as bones release calcium into the blood to maintain the normal level. Osteoporosis refers to decreased bone density. Osteoporotic bones take up less calcium than healthy bone tissue. Women are at increased risk for osteoporosis because women consume less dietary calcium than men. Also, after menopause, women may lose up to 20% of bone mass. In women, estrogen levels have a protective effect for our bones. In order to prevent osteoporosis, it's important to get adequate calcium and adequate weight-bearing physical activities, which include things like jogging and jump roping. Weight-bearing activity increases the amount of calcium that your bones take up. In Table 9-6, the risk factors for osteoporosis are listed. The modifiable risk factors include things related to diet and lifestyle. Non-modifiable risk factors for osteoporosis include female gender, being of older age, having a smaller frame, being of Caucasian, Asian, or Latino heritage, having a family history of osteoporosis or fractures, and also hormones. Estrogen deficiency in women due to amenorrhea, which is lack of a menstrual cycle, or due to menopause, which is cessation of menstruation in one's lifetime. And also testosterone deficiency in men can also increase their risk for osteoporosis. Glucocorticoid drugs that suppress immune response are associated with an increased risk for osteoporosis. So it's very important to pay attention to calcium intakes and weight-bearing activity, since you are at increased risk if you take a glucocorticoid or certain anticonvulsant drugs. Adequate calcium intake is associated with reduced hypertension risk and may play a role in having a healthy body composition. The RDA for calcium during adolescence is 1,300 milligrams. It is slightly lower for adults aged 19 to 50 years, and it increases again for women over the age of 50 and men over the age of 70. The best sources of calcium include milk or plant-based milks that have been fortified with calcium and vitamin D. So whether it's soy milk, almond milk, or oat milk, or dairy milk, consuming calcium and vitamin D in regular intervals throughout the day will maximize absorption of calcium. Turnip greens, broccoli, cheese are all good sources of calcium. Spinach contains a lot of calcium, but binders in spinach, like phytates, will decrease the amount of calcium that can be absorbed from spinach, and some other vegetables are like that. Some good sources of calcium are shown here. Broccoli, kale, and some other cooked green leafy vegetables can be sources of calcium that are bioavailable. Some greens like spinach contain calcium in an unabsorbable form. Also, since we're talking about absorption, the older we get, the less calcium we tend to absorb. Vitamin D helps aid in absorption of calcium. Phosphorus is the second most abundant mineral in the body behind calcium. It is also found in the bones and teeth. Phosphorus is also found in all body tissues. It is part of our DNA and RNA, and also part of phospholipids that transport lipids throughout our body, and found as part of our cell membranes. Deficiency symptoms are unknown. Toxicity, having too much, is associated with calcification of our tissues, especially our kidneys. The best sources of phosphorus include animal proteins, milk, and cheese. Magnesium is also found in the bones. Magnesium is present in the muscles, the heart, liver, and other soft tissues, and there are small amounts present in the body fluids. Magnesium is important for the function of hundreds of enzymes. It is also needed for bone mineralization. It's needed to build proteins for normal muscle contraction and for the transmission of nerve impulses. Someone who is deficient in magnesium will experience muscle cramps. They may experience low blood calcium, confusion, possibly seizures, and bizarre movements. They may also hallucinate and have difficulty swallowing. Magnesium toxicity is rare, but can result due to ingestion from high non-food intakes of magnesium from supplements or magnesium salts that may be sold as pharmaceuticals. The best sources of magnesium include nuts, legumes, which include beans, whole grains, dark green vegetables, seafood, chocolate, and cocoa. Good sources of magnesium from your textbook provide 10% or more of the daily value of magnesium, which is 420 milligrams per day. Spinach, black beans, fortified cereals, oysters, yogurt, and soy milk are all good sources. Sulfur is the last major mineral. It is referred to also as sulfate. Sulfate is the oxidized form found in foods and water. Sulfur is needed for sulfur-containing enzymes. It is a component of certain amino acids and also a part of the vitamins biotin and thiamine. It is also part of the hormone insulin. Sulfur helps stabilize protein structures. For example, protein structures of our skin, hair, and nails. There is no recommended intake of sulfur. A protein deficiency would occur before a deficiency of sulfur. Toxicity may occur if someone were to overconsume excess sulfur-containing amino acids. Toxicity can possibly suppress growth. All protein-containing foods contain sulfur. Table 9-8 lists a summary of the major minerals. Iron is an important trace mineral that is tightly regulated in part by the transport protein transferrin and the hormone hepcidin. Iron is an important component of hemoglobin, which carries oxygen in our red blood cells, and myoglobin, which carries oxygen in our muscle cells. Iron is a powerful oxidant, meaning that it can generate free radicals. Free radicals are not good for our health when we are exposed to excessive amounts. Free radicals are associated with increased risk of chronic disease and certain types of cancer. Iron is lost through shedding of our skin, our GI tract, our hair, and our nails. In terms of absorption, about 10 to 15% of dietary iron is absorbed in an adult, but if needs increase, that absorption rate can also increase. Transferrin is a transport protein that carries iron in the blood. Whenever more iron is needed by the tissues, more transferrin is made. Hepcidin is a hormone that is secreted by the liver whenever blood iron levels are elevated. Hepcidin works to decrease iron absorption from the small intestine and decrease the amount of iron that is released from storage. Iron deficiency is the most common nutrient deficiency worldwide. Iron deficiency affects an estimated 2 billion people. Women who menstruate are at increased risk for iron deficiency. They need 18 milligrams of iron per day. Also, needs for iron increase during infancy, young childhood, adolescence, and pregnancy. The causes of iron deficiency include inadequate dietary intake or blood loss. Iron deficiency will happen in 3 stages. In the first stage, both the iron stores and the level of ferritin, which is the stored form of iron, will both decrease. In the second stage, transferrin levels will increase, and there will be less iron available in the blood. In the third stage, the deficiency of iron starts to affect the amount of hemoglobin that gets produced. Levels of hematocrit will also decrease. An anemia will arise if iron deficiency advances far enough. some people can be deficient and not anemic. Anemic refers to a condition in which the blood cells do not function properly, or they are too few in number. You can have a B12 or folate deficiency, and that will produce a macrocytic anemia. With an iron deficiency anemia, the red blood cells will be small and pale because they contain less hemoglobin. The picture on the left from your textbook shows normal red blood cells under a microscope, and on the right you see iron deficient red blood cells. They are small and pale because they contain less hemoglobin. Iron deficiency can also result in headaches, trouble concentrating, impaired cognitive function. You might feel cold all the time. Also, it can cause pica, which is craving non-food items like ice, dirt, or even salt, or laundry detergent. If you think you may be deficient in iron, get some blood work. Iron overload is called hemochromatosis. This can result due to excessive blood transfusions. Some people who have sickle cell anemia, for example, may suffer with hemochromatosis due to receiving a lot of blood transfusions. Usually, iron overload is hereditary. There is a defect in iron absorption. Toxicity symptoms of iron overload include infections, liver injury, possible increased risk of heart attack, bloody stools, and shock. If you take a supplement, take it every other day. The recommendations for iron in women of childbearing age is 18 milligrams per day, and in men it's 8 milligrams per day. There are two types of iron that we can get from food: heme iron and non-heme iron. Heme iron is found as part of meat. 23% of heme iron is absorbed. 2 to 20% of non-heme iron is absorbed, and this is found in plants. Most women don't get enough iron in their diet until after menopause. Some good sources include spinach, fortified cereals, clams, and steak. Beans have iron, but phytates in beans can reduce iron absorption. Iron deficiency is pretty common, especially among women. Zinc is important for activating a number of enzymes. Zinc deficiency is not common in developed countries. However, some groups may be more vulnerable to zinc deficiency, like the poor, older adults, people with poor food intakes, women who are pregnant, and young children. It can cause changes to immune system response and can cause problems with activating vitamin A to its active form, so can cause problems with vision. The main way zinc is transported is via the abundant blood protein albumin. How does the body's handling of zinc resemble that of iron? Well, like iron, extra zinc that enters the body is held within the intestinal cells, and only the amount needed is released into the bloodstream. Zinc status influences the percent of zinc absorbed from the diet. If more zinc is needed, more will be absorbed from the diet. Mild zinc deficiency can cause a problem with the immune system, but I don't recommend taking a whole bunch of supplements. If you take a supplement because you've assessed your diet or had your diet assessed to find out that you may need zinc, get one that is close to the RDA. With minerals especially, taking them as a supplement will cause GI distress when you take too much. If you're taking 50 milligrams of zinc, then you probably will have some GI upset if you're taking that on an empty stomach especially. So be careful with that. The RDA for zinc is 8 to 11 milligrams, 8 for women and 11 for men. Zinc is abundant in high protein animal foods. So if you consume a lot of high protein animal foods, then your diet is not likely to be deficient in zinc. But if you don't, then it's possible that you may be zinc deficient. Good sources of zinc besides meat include yogurt and enriched or fortified cereals and oysters and shrimp. Selenium is an antioxidant nutrient, meaning that it functions to stabilize free radicals. Having adequate blood levels of selenium has been protective against prostate cancer and some other types of cancer like colon cancer. Selenium is needed as part of the thyroid hormones. Deficiency of selenium is associated with a heart disease called Cachon disease. And this occurs in places where people consume foods in areas where the soil is deficient in selenium. Selenium toxicity can occur with excessive intakes of selenium-rich foods. Selenium is widely distributed in meats and shellfish and Brazil nuts. Vegetables and grains that are grown in selenium-rich soil also provide a good source of selenium. The RDA for selenium for adults is 55 micrograms. 1 ounce of Brazil nuts, which is 6 to 8 nuts, contains 544 micrograms. Iodine deficiency is a disruptor of many of the body systems. The thyroid hormones regulate metabolic rate, reproduction, growth, body temperature, blood cell production, and also it affects the brain. Iodine deficiency is the most common cause of preventable brain damage in the world. An estimated 1/3 of school-aged children have an iodine deficiency. Having too much or too little iodine can result in enlargement of the thyroid gland, called a goiter. Iodine intake may be less than desired in young women. In the United States, iodine intakes on average are slightly above the RDA. Sources of iodine include iodized salt and seafood, and even sea mist is mentioned as a major source of iodine. Copper is an important mineral that is needed for the functioning of a number of enzymes. Copper is also needed for the absorption and use of iron in the formation of hemoglobin. Copper deficiency is rare. High intakes of zinc can interfere, however, with copper absorption and lead to deficiency. Deficiency can result in anemia and some bone abnormalities. Some genetic disorders may be responsible for copper toxicity, but it is unlikely to get too much copper from food, but a UL is set for copper. Manganese, not to be confused with magnesium, is a facilitator of many metabolic processes and a cofactor for many enzymes. Deficiency of manganese is rare, however, toxicity symptoms can include nervous system disorders and problems with your brain. It can cause you to lose your mind. Fluoride is needed for the formation of both teeth and bones. Fluoride helps to make the teeth resistant to decay. An important source of fluoride includes, important sources of fluoride include fluoridated water. Some people do not have access to fluoridated water, but also toothpaste and mouthwash even. A deficiency of fluoride can increase susceptibility to tooth decay, and getting too much can cause fluorosis, which is the pitting and discoloration of teeth. It can also lead to bone abnormalities. Fish may also be a good source of fluoride. Chromium is essential in carbohydrate and lipid metabolism. It enhances the action of insulin and may improve glucose tolerance. A deficiency of chromium can cause problems with glucose homeostasis and lead to a diabetes-like condition. The best sources of chromium in the diet include whole grains and unrefined foods. Molybdenum functions as part of enzymes. They are called metal-containing enzymes. There are a number of other trace minerals that may play roles and contribute to our health. They include nickel, silicon, cobalt, and boron. Read about vitamin and mineral supplements in the Nutrition and Practice section at the very end of this chapter. It's a very interesting read if you are curious about whether you need a supplement. Most people don't and can obtain nutrients from their diet by consuming a well-balanced diet. Some people may be at risk for deficiencies, like people taking certain types of medications, and may require supplementation. Vegans may choose to take a vitamin B12 supplement or may choose to consume foods that have been fortified with vitamin B12. For example, when choosing a supplement, try not to go over the UL for that supplement. Some supplements may pose toxicity risk and may be contaminated with drugs or poisons. The United States Pharmacopoeia is an independent testing lab that supplement manufacturers can pay to have their supplements tested to get the USP mark. The USP mark ensures that the supplement contains what it's supposed to contain and is at the advertised potency. It does not verify health claims made by supplement manufacturers, however. If you have any questions, let me know.